Question number 10. If three lines whose equations are y is equal to m1x plus c1, y is equal to m2x plus c2, y is equal to m3x plus c3 are concurrent, then show that m1 in bracket c2 minus c3 plus m2 c3 minus c1 plus m3 c1 minus c2 is equal to 0. So we have to show that m1 in bracket c2 minus c3 plus m2 in bracket c3 minus c1 plus m3 in bracket c1 minus c2 is equal to 0. We have to show that. So first of all we have to find y. From first and second equation we have to solve for x. Then we have to solve for y. Okay. Let's do the problem. These three lines are congruent. Given three lines are congruent, it means these three lines passes through one point. So the coordinates we get xy. These xy satisfies this equation. We get then we have to show that m1 in bracket c1 minus c3 plus m2 in bracket c3 minus c1 plus m3 in bracket c1 minus c2 equal to 0. Given lines are y is equal to m1x plus c1, y is equal to m2x plus c2, y is equal to m3x plus c3. Solving 1 and 2, we get, that is subtracting 1 minus 2 we get y minus y is equal to m1x plus c1 minus m2x plus c2. Okay, in bracket you have to put. Then y minus y is equal to how much? 0 we get, isn't it? Which is equal to m1x c1 m1x plus c1 minus, remove the bracket, minus m2x minus c2 we get. Then we have to 0 is equal to m1x minus m2x, regroup this term and this term we have to regroup. So m2x plus c1 minus c2. Transpose this c1 minus c2. So this becomes minus bracket c1 minus c2 we get, which is equal to m1x minus m2x we get. Okay. Then we have to remove the bracket. So we get minus c1 plus c2 we get, isn't it? Which is equal to m1 minus m2 x. X is the common factor here. So x we get. Then we have to arrange this. Then c2 minus c1 is equal to m1 minus m2 into x. Then x equals c2 minus c1 whole divided by m1 minus m2. So which implies x equals c2 minus c1 whole divided by m1 minus m2. Okay. So we get the x values. Substitute Substitute x in equation 1, we get equation 1, we get, what will you get then? Y is equal, what is the equation 1? Y is equal to m1x plus c1. So y is equal to, what is x here? c2 minus c1 whole divided by m1 minus m2 plus c1, which implies y equals m1 into c1 minus c2 minus c1 whole divided by m1 minus m2 plus c1. Substitute x and y in equation 3. What is equation 3? Equation 3 is y is equal to m3x plus c3. This is equation 3. So what is y here? Y value is what? m1 into bracket c2 minus c1 whole divided by m1 minus m2 plus c1, which is equal to, what is x here? X equal to c2 minus c1 whole divided by m1 minus m2 plus c3. Okay, then we have to find the LCM, isn't it? So we have to find the LCM. So we get like this, m1 c2 minus c1 plus c1 into m1 minus m2 whole divided by m1 minus m2, which is equal to, we can write like this. This also we can take LCM. So we get m3 into c2 minus c1 divided plus c3 into m1 minus m2 whole divided by m1 minus m2. Then next step, we have to remove the bracket, which implies we can write m1 c2 minus m1 c1 plus m1 c1 plus, so here minus, so minus m2 c1, which is equal to m3 c2 minus m3 c1 plus m1 c3 minus m2 c3. Here LCM is what? m1 minus m2. Here also LCM is m1 minus m2. Okay. So these m1 minus m2 and these m1 minus m2 gets cancelled. Okay. And what is remaining? We get okay. Next, these term and these term gets cancelled. So what is remaining? We get M1C2 minus M2C1. Transpose these terms to this side. So we get minus M3C2 plus M3C1 plus M1C3 transpose to this side, so it becomes minus. So this term is minus, then this term become plus M2C3 which is equal to 0. Next step, we are going to combine these terms. M1C2 and these M1C3 we have to combine. M1C2 minus M1C3, then minus M2C1 and M2C3 we have to combine. So minus M2C1 plus M2C3 plus M3C1 and minus M3C2 we have to compare. M3C1 minus M3C2 which is equal to 0. Next step, which implies what is the common factor here? M1 is common. But M1 into C2 minus C3. From here, what is the common factor here? Plus M2 into C3 minus C1. Then plus M3 into C1 minus C2 is equal to 0. Hence the proof. Thanks for watching.